So we are moving on to chapter 4. We will only do 2 sections. We'll do 4.1 and 4.2, and then you'll have a quiz on Friday that will be 25 points quiz. Well, it'll be 25 points in the test. Nope. All homework is due on Friday. So, just so you know. I will not be grading any homework in here after Friday. Okay, so the definition of an antiderivative. You're going to catch me calling it an integral, and that's what the sign is, but just know it's the same thing. So if f is an antiderivative of f on an interval of I, then f prime of x equals f of x for all x in I. So what that says is f is an antiderivative, so what would anti mean? Opposite. So you're undoing a derivative. So it's saying f prime equals f if it's the antiderivative. We're going to take a derivative back to the original function. That's pretty much all that's saying. And when I say those two guys, it's not necessarily like important that you know that definition, but it's important that you learn to decipher what the book is saying. And I'm going to tell you under that box would be the most helpful information ever. Okay. So it says find f whose derivative is f of x equals 3x squared. So that means we have to go backwards. Like, where did it come from? Does that make sense? So if we do derivative, like we take, if we had x squared, the derivative is 2x, correct?
Yeah.
Okay, so we need to think about, and I will give you a better way to do this than right now, but I just want to think about, see if we can figure it out. So we have to go backwards. So whatever was here, this 2 used to be a what? 3. It was a 3, so we had x cubed, yes?
Yeah.
So we multiplied the front by 3. So what was there? 1. So f then just equals x cubed.
Plus or minus anything.
And you're right, plus or minus anything. We're going to talk about that because there could have been a constant behind it, yes? And actually, we're just going to put plus the constant because of the fact that if it's a negative, then it would be a negative, whatever. Okay, so note that f is called the antiderivative of lowercase f rather than the antiderivative of f. So if I have f sub 1 is x cubed, and f sub 2 is x cubed minus 5, and x cubed plus 95, wouldn't all of their derivatives be exactly the same?
Yeah.
Yes, because a constant doesn't change it. So all antiderivatives of 3x squared, are included if I would just say that plus c. We don't know what it is, but it is there, or it could be there, it could not be there, but we don't know. Does that make sense? So when you take an antiderivative, you have to put what behind it? Plus c. Natalie, let me know when I'm good.
Okay, just let her know when I'm waiting on you.
Stop.
Just why don't you buy a cake this weekend?
Okay, and here is in the book definition of this, so you can see what they say, but you probably don't want to do write anymore. So if f is an antiderivative of f on the interval I, then g is the antiderivative of f on the interval of I, if and only if g is in the form of g of x equals f of x plus c. Meaning that we've added that constant there, and all x's in I where c is a constant. All this said is g, and g stands for general solution. Okay, this is known as a general solution because we don't know what C is. We will have to find a particular solution, but not today. Please do not write this down.
Okay, I will.
Okay, other than maybe two things. It says theorem 4.1, you can represent the entire family of an antiderivative. So when we do this, we just had x cubed plus 97 and x cubed minus 5. That's the cubed. Okay, so these are one solution, yes? But when we did the x cubed plus c, what we made was a family, what they call is a family of antiderivatives, because it could be anything. Okay? C is called the constant of integration. You might need to know what that word is. C is the constant of integration. And the whole thing is called the general, I called it solution, and I should have said general antiderivative. Well, no, they said solution. I'm not completely wrong. G was the general antiderivative, and this part over here is considered the general solution. So we will be finding general solutions the majority of the time, but then there's times where you have to find a particular solution. I need to paraphrase this slide, but I don't want to leave the words out, so I put them all there, but you don't need to write them all down. You know what a differential equation is, correct? It's y prime equals 3x. We've solved those, right?
Okay.
And you have y prime equals x squared plus 1. So when we solved those, we made it equal to the derivative when we solved them. So what we're going to be looking at is those. So we are looking at a differential equation, and then we're finding the antiderivative of it. So we have find the general solution of the differential equation y prime equals 2.
G.
So another way to write this would be dy over dx equals 2. Correct?
Yeah.
Okay, so if I had this, dy over dx equals 2, I would multiply both sides by dx. So I have dy equals 2 dx. So what we are then going to do is we are going to integrate both sides, and that's really funny that this symbol came down at the bottom because I'm going to show you what an integral is real quick. So you have the integral and the integral. So you're integrating both sides, which is finding the antiderivative. It's the process. Look at the symbol down at the bottom. Doesn't it kind of look like it? So what would be the integral of the derivative of y? Wouldn't it just be y? So again, I haven't told you how yet, but in order for us just to get x, 2, just to get 2, where did it come from? No, because there's no x there. So it would have had to been x to the what? It would have had to been x to the first, wouldn't it?
Yeah.
So what would have had to been in front? 2. So it would have had to be 2x plus c. So it's going to be important for us to find that exponent first, isn't it? Then we can figure out, and I will give you a better way to do this. So don't worry, it's not just going to be a guessing game because you know they're going to get harder. Making sense so far? So how could I check this? I differentiate it. So if I have y equals 2x plus constant, doesn't matter, right? So what's the derivative of constant? 0, and the derivative of 2x would be 2.
Calc.
Okay, why are you laying all over the table?
C.
Okay, so we just had, I know it went away because this should have been on the same slide. So we came out with f equals 2x plus c, yes? And we know that a derivative is the slope of the tangent line. So we have equations. 2x is linear, obviously. And as I'm changing that c, what am I changing in y equals mx plus b?
Intercept.
The intercept. So as I change that, it would not change the slope. It would change the y-intercept. Make sense? What would happen? So these are all in the family. Okay, so I've used these words already. When we anti-differentiation is called indefinite integration, and we tend to just say find the integral because this symbol right here is called the integral. So integrate, find the indefinite integration, or find the indefinite integral. It all means the same thing. And we read it as the integral, well, no, antiderivative of f with respect to x. So I have this right here. So the integral means antiderivative of what? F with respect to x. That dx still means with respect to. Now I'm going to say, you guys will hardly ever say the antiderivative. You're going to say the integral of whatever. This over here is just the setup I've shown you, that y equals the integral of f of x dx, which is equal to f, meaning the antiderivative of x plus c. And c is that constant of integration. So just like when we found derivatives, we rewrote things to make them easier to work with. Guess what we're going to do again? Rewrite them to make them easier to work with.
You can go on.
Okay, I'm just making sure. I was being nice. Basic integration. It's just the inverse. You undo it. If you find the check, we've already talked about it. If I find the integral, how am I going to check it? Find the derivative. And we do take the integral with respect to. So we can take it to with the respect of y. We can just take it to the respect of x. You do have to integrate the correct variable, and we will do some integration, some explicit integration as well. We did explicit differentiation, so you have to do explicit integration as well. So it's just like when you learn to multiply, could you divide before you learn to multiply? Probably not. Okay, on page 250, I am not going to sit here, and I have suggested to you guys that you start a derivative sheet. I would assume that you have that. I don't think all of these things would be on there. I do not expect you to have, like, the derivative of a constant is 0. Would you have that on your sheet?
Yes. Natalie might.
But on page 250, this is where this lies. It is a whole big chart. If you notice, we have the derivative of a constant is 0. So the integral of a 0 is a constant, which I don't know why you would integrate 0, but I guess you could. If the derivative of kx is k, then the integral of k is kx plus c. So these are written side by side so you can kind of see them and see how they affect each other. Okay. The biggest thing is going to help you out is probably with the sine, cosine. Like right now, this would probably be where I would think you would need. I typically do not write both because if I know the derivative of sine is cosine, then what's the integral of cosine? Sine. After you do this a while, you won't want to write both because you don't need both. Does that make sense? So, yeah. Am I good? Okay. So, describe the antiderivative of 3x. Basically, it just says find the derivative of 3x. So, we're going to take the whole thing. So, dy dx of 3x. Oh, wait a second. I got to go back. Sorry. The power rule right here. This is what we've been doing and you didn't know you were doing it. Okay, one of the first derivative rules we learned was the power rule, correct? Subtract 1, multiply, subtract 1. Okay, so we're not going to subtract 1, we're going to what? Add 1. We're not going to multiply, we're going to divide. So the power rule is right here. Subtract 1, multiply. So now we're going to add 1, divide. That is the basic rule we're going to start with. Adding 1, divide. So we're going to try to set everything up so we can use this power rule. Do you guys want to write this down on your paper?
I guess.
I would highly suggest you get these in your notes. Not right now, but in your notes tonight when you're doing homework. Now, I will want to point out real quick again, the integral of 0 is a constant, yes? The integral of a variable is, of a constant is that constant and the variable dx, whatever you're doing, plus c. We have the constant rule. We can kick it out in front of the integral. And we also have where we can add and subtract. We can break it up. So if I have f of x plus g of x, I can break it to the integral of f of x plus the integral of g of x. If I can take the derivative of that way it makes sense that I can do an antiderivative that way. It's one of those things that you shouldn't think about. You should just do it because that's how you would do the derivative. Okay, so now let me go back to here. So we have dy dx of 3x dx. And that dx has to be there. Oh, it's not dx yet. How do I get that dx?
5.
Multiply it over. So we're going to have the integral of dy equals the integral of 3x dx. Now, I am going to tell you that sometimes you need parentheses around there because you got too many x's wandering around. After this one, I will not put integral of dy. I will just put y because the integral of the derivative of y is y. So my rule is I can bring the 3 out, correct? So I have 3, the integral of x dx. So my power rule says it's going to be 3 times. Now your power rule says whatever you have, right? So we have x to the first. So x to the 1 plus 1 over 1 plus 1 plus c. Well, look at the denominator. What's 1 plus 1?
Wow.
2. So 3 over 2 x squared plus c. Now this is very spelled out. We are not going to, probably by the end of today, you are not going to be doing this many steps to do these. No, because you're going to add 1 and divide by it. That's what you do. So if I wanted to check it out, I would just take the derivative. If I took the derivative, I'd have 3 times 2, x to the first, plus some constant. So it'd be 3x plus some constant. Do I get the same thing? Yes, because that constant can be 0. Okay, so in the book, they like to do the rewrite, integrate, simplify. Okay, I don't care if those are the things that you're doing. I showed you this, but I'm going to work probably every one of them down because that's, well, they're not very many steps. Yeah, we're going to work every one of them down just because that's how you should be working them. Okay, how do you think we're going to rewrite the first one? If you were differentiating it, what would you do?
X to the negative third.
Yep. So we had the integral of 1 over x cubed dx. Oh, shoot.
You don't.
Yes, I do. I guess I'm going to work these way because I don't want to do it. So it's going to be the integral of x to the negative third dx. So that's my rewriting. My integration is to add 1 and divide, right? So I have x to the negative 3 plus 1 over negative 3 plus 1 plus c. So we're going to have negative 1 over 2x squared. How did I jump from one to the other? Because this is going to be x to the negative second, yes? And so I have to bring it back out, down into the denominator. Make sense? Am I going too fast? Okay, so I have the integral of the square root of x dx. So how am I going to rewrite that?
X to the 1/2.
So I'm going to have x to the 1/2 dx. You guys want to try this one on your own?
Sure.
Okay, did we end up with 2/3 x to the 3/2 plus c? Natalie?
Very close to.
Okay. Did you forget to multiply by the reciprocal? Okay. So now we have integral of 2 sine of x dx. So I'm going to rewrite it as 2 the integral of sine of x dx. So we can look at the sheet, but we also can think, what gives me a derivative of sine?
Negative cosine.
It'd be negative cosine, because the derivative of cosine would be negative sine, correct? So I have 2 times negative cosine of x plus c. So it's negative 2 cosine of x plus c. Now, I'm going to tell you with sine and cosine, just like when we took the derivative, we're just like, this is what it is. when you take the integral, everyone wants to go, they want to go backwards, the steps backwards. We're not adding one and dividing by it because that's not how those work. It just is. So do you just need to know them? Yes. Again, if you don't have an integral sheet together or derivative sheet to add the integrals, you need to get one now. Okay? And I would suggest every time I add a new rule that you take some stuff off. After we come back from break, give yourself a week or so and then take those top 5 off of there because you shouldn't need the basic integration or differentiation rules. You shouldn't need them. Okay, integrate the polynomial function. So I have the integral of dx. What's in front of that dx? A 1. So that would be a constant, yes? Mm-hmm. So what was it? X to the what before?
The one.
It's first, right? So it's just x plus c.
Yeah.
And that was the second one, right? Because it was the integral of a constant, was the constant plus, or constant times x. It is. Okay, so on B, we have the integral of x plus 2 dx. So we need to rewrite it as the integral of x dx plus the integral of 2. Oh, the 2 can come out in front, can't it? So 2 integral of dx. Now, give yourself a little bit of time and you won't be writing these out. You'll just be doing them just like when we did the derivative. You just did them. Okay, so how am I going to find the derivative of x?
We're finding the derivative of x?
Well, sorry, the integral of x. It was 1, right? So we add 1 and divide by it.
Yep.
So 1 plus 1 is 2. So can I just write it as 1/2 x squared? Everyone okay with that one? Plus, well, what's the integral of dx? X. So plus 2x plus c. So the next one's probably the last time I'll ever write them out like this. So we got what? 3, the integral of x to the 4th dx, minus 5, the integral of x squared dx, plus the integral of x dx. Am I good to start? So how did it go? Almost. The screen's really small. Good?
Mm-hmm.
Okay. Okay, so just more different that we need to rewrite. Well, you don't know a quotient rule yet, do you?
Mm-hmm.
No. So can I divide both things in the numerator by the denominator? Could I? Could I write this as the integral? Oops. So this is x to the 1/2, yes?
Yeah.
So I can divide this and this by x to the 1/2, can't I? Okay, so x to the first divided by x to the 1/2 would be x to the 1/2. And 1 divided by x to the 1/2 would be just x to the 1/2. Oops, I forgot my dx's. So 1/2 plus 1 is?
1/2 plus 1 is 3 halves.
So 3/2, and then multiply by the reciprocal, which would be 2/3. And then we're going to have a minus, aren't we? Nope. So then 1/2 plus 1 is, or negative 1/2 plus 1 is 1/2. And the reciprocal is 2. Okay, so now then we got integral of sine of x over cosine squared of x. So again, we do not have a quotient rule for this, do we? No. But I want to take a minute to think about, do you guys have the problem written down?
No.
Okay, write the problem down. Got it down now? Okay, so I'm going to go back here. And I want us to look at the integrals and see if we could rewrite the integral of, what was it, sine over cosine squared? Sine of x over cosine of x squared to fit one of
Letter D.
D. We have a D?
The fourth one down.
Oh, the fourth one down. So Kale says, I can rewrite sine over cosine squared of x to be secant and tangent. How, Kale?
Well, sine over cosine, tangent, you have 1 over cosine left.
So we're going to rewrite this as 1 over cosine times sine over cosine. So then you have the integral of the secant of x, tangent of x, tangent squared, no, tangent of x,
Junior high girls basketball players
dx.
are dismissed.
Well, the derivative of secant of x is what? Secant tangent? So do you see how you can use your derivatives to do integrals? You don't have to have both. So it is the secant of x plus c. That's it for today. Everyone's going to be here tomorrow.